Saxon Advanced Mathematics, Lesson 81. Today, our topic, my friends, is the law of cosines. What? There's a law of cosines too? Yes, there is. Let's just review the rules for trying to solve triangles. Every triangle has 3 angles. And 3 sides, right? So that's 6 parts. Every triangle, I should have written that first, has, right? If we know one side and 2 other parts, sides or angles, we can solve. Okay? We can't know all 3 angles. That wouldn't work, but just about every other combination will work, right? One side and 2 other parts we can solve. 1, if it's a right triangle, we use sine, cosine, or tangent, right? The standard features of those, right? 2, if not a right triangle, but we have a matching pair, and by that I mean a side and an opposite angle, right? So if we have a side and the opposite angle, we use the law of sines. Ready for number 3? If not a right triangle and we don't have a matching pair, a side and an opposite angle, we use the law of cosines, and that's what I'm going to teach you today. All right, so the good news is we can use the law of cosines to create a matching pair, and then we can use the law of sines to finish solving that triangle. Grace, we're teaching. We're right in the middle of the lesson. I can't fool around with you right now. She came over, I'm petting her. I'm sorry. Here, put your nose on the paper so everyone can see you. There. Oh, there she is. I don't have time for you right now. I'm sorry. I'm engrossed in a very fascinating conversation about the law of cosines, and you have to cope. Let's see if you can do it. I think she can. I'll open the door if she gets really crazy. There's no cookies out. Do you need to go out? There, go cause trouble. She's going in the kitchen unattended. Lord help us. But there's no food out, so she should be fine. Okay, so here is the formula for the law of cosines. The first thing we do is we choose a pair, a side and an angle, that we wish we had. Okay? Little p, which I like to do with a little cursive thing in the front, just to help me remember, that is the side. And big P is the angle. Grace is barking. I might have to go deal with her. And the formula that we use is P squared equals, oh good, my daughters are coming to the rescue. Okay, it looks complicated. Basically what we're doing is kind of riffing off the Pythagorean theorem. I'm not going to go into a big thing about the theory behind that, but just know we're working off the Pythagorean theorem. And these are obviously A and B are the sides we do have, right? And we can do this to solve for the side, or we can do it to solve for the angle. Okay, we'll do it both ways, I think, in this lesson. That looks confusing. Let's run through one or two and you'll see how it works. I'm going to copy it again right here. Thank you. Is that Tessa? Okay, solve the triangle for its unknown parts. Okay, so let's pretend we don't know that this isn't a lesson for the law of cosines. Let's just pretend. And let's just write in some information. 7x, 10, y, 36 degrees, m. Okay, we have one side and two other pieces, so we should be able to solve it. It's not a right triangle, so we can't use regular trig functions. We don't have a matching pair, right? Because there's a mystery, there's a mystery, there's a mystery. So what we have to do is just pick one of these pairs and solve for the missing part using the law of cosines. Now, it doesn't matter which pair because we can use this formula either way, but I like to use it where I have the angle. Okay, so this is my little preference. It's not a rule, but I just think it's easier. It's better if you know the angle and the side is the mystery, because look how the formula is set up, right? The angle is buried in this calculation, but there's the side right there. So it's a lot easier to manipulate this in order to solve for that. So what we're going to choose to do, we're going to say that the pair we wish we had is this. So we're going to let lowercase p equal x, because that's the side, and we're going to let big P equal 36 degrees. Okay? So that's step number one, is we choose which pair we wish we had. And we plug those values in as 36, as P, little p and big P. Little p for the side, big P. Now we can plug the whole thing in, and we also see that A equals we've got 7 and 10. So we'll let A equal 7 and B equal 10, right? The other two sides. All right, so now we are ready to plug this whole creation in. So we're going to fill in with this. So I'm going to set it up just like we do the quadratic equation. Doesn't all fit in one line. Oops. These are squared also. Okay? So this is this set up with open buckets for the variables. P is x. We'll put in the variable that makes sense. Here's my angle, 36 degrees. A is 7. And B is 10. Okay? So now we can do some simplifying, but we are going to use calculators on this. So go ahead and what I encourage you to do, you guys, is do as much of this in your head as you can. Like I can go x squared equals 49 plus 100, and then I can see it's minus 140 times the cosine of 36 degrees, right? I don't have to be just a complete baby about doing the whole thing. Get it simplified as much as possible. Now use your calculator. 36 degrees cosine times 140. Change the sign of it to minus and then add 149. And then you'll get x squared equals, let's see, this much of it, you'll get 113.26. And then you'll add all that and you'll get x squared equals 35.74. And then you'll square root it. X equals 5.98. We can discard the negative root because I'm pretty sure that's not a negative number. And there now we have x equals 5.98 units long. Thank you, Law of Cosines, for helping us get that. Okay, now we've got a pair, don't we? So now we can kick in and use the law of sines. Right? That kicks in right here because now we've got a pair. We've got 5.98 over the sine of 36 degrees. See how I change? Up here, we didn't have a pair, so we used the law of cosines. Then once we get the pair, we can change gears and use the law of sines. Okay, and we will use it, I will show you both calculations. Let's do it for this one. It'll be 10 over the sine of x degrees. Oh, I'm sorry, y, right? Because that's the matching pair. And then we'll use it again, 5.98 over the sine of 36 degrees equals 7 over the sine of m degrees. And when we do the calculations, we find out that y equals either 79.39 degrees or we've got that ambiguous result thing, right? Or 100.61. If you have any trouble with these calculating things, text me right now. If you're not able to get these answers, text me right now. Pause this video and say, this is a nightmare. Help me. M is 43.47 or 136. 0.53. Those are our two options. So now we go back to our triangle and we figure out, okay, what's going to make the most sense here? That's 36. M is definitely the 43, right? We know that for sure. And so we can do the math to figure out which one it might be for y. Because honestly, I can't tell just by glancing at that whether that's larger than a right angle or less than. And these are closer. It's much easier to discern with these two because this angle is clearly not 136 degrees. Clearly. So I'm going to do a quick little jaunt on my calculator. Except I don't have my calculator. But 36 plus, I'm just going to say 43 for purposes of rounding. That much is 79. So I know that this one, I need the one that is 100, don't I? It's got to be this one. Because I need about 100 more to get me, I need 101 to get me to 180, right? Which is what I need for the three angles. So if you have multiple ambiguous angles, in some ways that's easier. Well, it's easier either way, but use your common sense, use your wits to decide on the one that's easier and then figure out the one that's harder. Okay, so these are the two correct answers. And of course, this was correct as well. Yay! So that's how our friend the law of sine works. We now have 2 more of these problems. Oh, we have 3 more. John is slaving us to death. Let's dive in and keep going. Example 81.2. Solve the triangle for the unknown parts. How did I know that's what this question would ask us? Drawing the picture is half the fun. 5, 7, and 8. And look at this. In this one, we have all sides and no angles. X, Y, Z. Isn't it cool to think that we're going to be able to figure this out? Even though we don't have any of the angles, but we know that these are the sides. Okay. So, I mean, honestly, it doesn't really matter which one we solve for, right? But John proposes that we start with this one and this one, which I would do just because it's alphabetical. It doesn't make any difference. So our little side P is 7. Our big angle P is X. Our A equals 5 and our B equals 8. Make sense? Now let me write the formula again. Little p squared equals, this is the part where it helps to remember that it's Pythagorean, but then this is the part that's weird. Cosine of big P. Okay, let's bracket. I can never quite get that last part squeezed in, and that's going to be X. Okay, so P is 7, A is 5, B is 8. All right, and this, I didn't put the squared there. All right, these first 3 are the part that reminds us the most of Pythagorean theorem. Okay, and remember, this is a minus sign. All right, we'll simplify as much as we can by hand, then we'll jump into the calculator. 49 equals 25 plus 64 minus 2 times 5 is 10 times 8 is 80 times the cosine of x. Now you see why it's easier to solve for a side than an angle, because we have to use algebra to get all of this out of the way. All right, which isn't the end of the world, but it's just more work. So let's see, this much is what, 89? So we have to subtract the 89 from both sides. Then we get what, minus 40 equals minus 80 cosine of x. We want this by itself, so we divide by minus 80. Aha, so then we get 0.5 equals the cosine of x. This means we need to use our inverse cosine, right? Use the second key and use this, because in this one we have the decimal and we want the degrees. If you do this, you'll find out that x equals either 60 degrees or 300 degrees. Well, there's no 300 degree angles in this. That would not work very well. So x equals 60 degrees. Make sense? Beautiful. And now we're all set up to use the law of sines, because we have a pair and we can go 7 over the sine of 60 degrees equals, let's see, which does John do first? 8 over the sine of y degrees. Alphabetical is the way to go. And then we'll do another one using the same anchor proportion for 5 over the sine of z degrees. We cross multiply, right? We get our values in there, and what do we get? Y equals 81.77 or 98.23. That's pretty close. That's going to be the hard one. Let's look at what the other one is. did John calculate z? You know what he did? Well, he did this. He looked at this for angle y, and he determined that angle y must be less than 90 degrees, so he did it just by looking. He chose the 81 because he decided that looked like it was less than that, and then he solved for z by subtracting. I don't like this. Okay, this was John's strategy. This is my strategy. And this is John's strategy. Here's what I think. Strategy. I spelled that wrong. Sorry. Here's what I think. I think that these two values are too close to call, and that in this case, the ambiguity is a problem, and I would go ahead and solve for z also using the law of sines, because that probably will give you two values that aren't so close, just like we did in that other problem, right? And then you can use the clarity of this answer to help clarify this answer. John just basically, in my opinion, took a guess over here, and then he solved for z using this value that he guessed at. If he guessed wrong, he just perpetuated his mistake into this. I think that's foolish. The right answer for z is 38.23 degrees. I do not have the, and this is the right value for y, the 81.77. I don't think you can call that just by looking at it, okay? So in a case like this, where you get two values that are so close, don't just guess. Solve the other one and see which one makes the most sense over here. Then you can use the subtract from 180 trick to get the right answer here. All right? Sean, I call you out. I call you out, sir. Okay, is there one more? No, there's two more. Let's see what we've got. Example 81.3. Solve this triangle for its unknown parts. Okay, well, we've got, look, an obtusity. All right, 10, 14. And this is lowercase k. It's that side. All right. Well, we don't have a pair, so we're going to need to start with the law of cosines to get this party going. Let's write the formula. Notice that when we make this here, we don't have to worry about which one's the hypotenuse, right? Because we don't technically have a hypotenuse because it's not a proper right angle. So the Pythagorean theorem is kind of a relaxed version of it because we can use the sides in any way we want in here. It's not like we're used to using the Pythagorean theorem where we have to put the hypotenuse and the legs separate. If that's been making you a little uncomfortable, that's why. It's because this isn't a right triangle to begin with. All right, we don't have a pair, so we're going to need to use the law of cosines. We could do it any way we want, but John says he would like to use 28 and k for the pair we wish we had. Okay, it doesn't really matter. Again, I prefer this way because I like to have the angle and solve for the side because that's the way the formula is set up. And as we saw in the last problem, you can do it the other way. It's okay if you know this side and you don't know the angle. It's just more algebra. But let's go ahead. There, I got it all in one row. Okay, we're going to use k for p. That means we'll have 10 and 14. Oh, I forgot to put the squares. There. 10, 14, and then our cosine will be 28 degrees. Oh, that's so much happier to me. All right, so then we'll get k squared equals 100 plus, what's 14 squared? It's 196 minus, let's see, that's 28, so 280 cosine of 28 degrees. Does that make sense? I hear you saying yes. I do. Okay, this value comes out to 247.23. And then we get a k squared value when we add those three. 100 plus 196 minus that, we get 48.77. And when we square root that puppy dog, we get a value of k for 6.98. Again, John says, now we have an interesting problem. K equals 6.98. Let me just write that, which makes sense because it's just under 49. Okay, here's what John says. When we know the lengths of all three sides of a triangle, we can find any of the missing angles by using the law of cosines. So we could use the law of cosines to find M or B. That's true, right? We could. We could use this formula to find any of them. But we have a pair, so we could also use the law of sines to find M or B. And then he goes through a big, long theoretical thing that I don't want to tell you about. So what he decides to do is he says, let's use the law of cosines again. Which you can totally do. He says, let's do it again. And this time, let's do it to solve for M. There's the M. So, P will be 14, and big P will be M degrees, right? So, here we go. Let's set it up. And then, of course, A will be, let's see, 14, and so A will be 10, and B will be 6.98. Okay, we use, there's the formula right there. So I'll use it again. It'll be okay, that's going to be the M. All right, P is 14, A is 10, B is 6.98. 6.98. I hope you can figure that out. You're good at this now, right? And so then we just keep solving away happily. We get 196 equals 100 plus, let's wait and see what the value for that is. Oh, it's 48.72, which we just lost a few. Grace, stay right here. And then this whole thing is minus 139 times the cosine of M. So we'll subtract 148.72. That all cancels. This will be a little less than 50, right? This will be, oh, John doesn't give me a value for that. He takes that and then he divides it by, he takes this number, which is about 48, so it'd be 48.2, 0.28, right? 0. $37. Yes. And then he divides it. Okay, so I swam the two squares over. I subtracted it. I got that. That leaves us with this. Then I subtract it by 130, or divide by 139. And I get, this is the solution he gets, 0.3387 equals the cosine of m, and then using the second inverse cosine button, we get m equals 109.80. And here's what's cool. Your calculator knows that if you're entering a negative value for cosine, it must be a second quadrant angle. Your calculator knows how to figure out the quadrant of that. So it automatically gives you that angle. Whoa, that's impressive, right? And now we've got two of the angles, so we can just subtract to get the third one. And B is 42.20. Okay, so there are the three values we calculated. So what I want you to see is that you can play around with these laws. You can use the law of cosine more if you like, right? Once you get a pair, you can switch over to the law of sines, or you can keep using the law of cosines. It's not a deal breaker. Okay, example 81.4 is a little bit of a story problem, if you will. The figure shows two cables that are attached to a vertical tower from a point on the ground. Okay, so let me just start drawing. Here's the tower, and there are two cables that are attached over here, like this-ish, okay? There's where they're both attached. This is the pole. Everything's perfect. The angle between the cables is 15 degrees. That's this. The longer cable is 150 feet long and is attached to the top of the tower. Okay, that's how we drew it. The shorter cable is attached to a point 50 feet below the top of the tower. Okay, so this side is 50. Those are my little foot marks. It doesn't really matter, the unit. Find the length of the shorter cable. Okay, so what we see is we're supposed to find, John calls it L, which I find frustrating, but we'll just call L. This is the length of the shorter cable. That's what we're supposed to find. So what we realize, excuse me, what we realize here is that we can use, it's hard because we have to just orient ourselves to this. Here's an angle and here's a side, right? This we can use as the law of sines but we don't have this angle that we would need. We don't have either of these, right? We don't have this angle. Let's just call it angle L with an uppercase, right? We don't have either of those. So while we have an anchor pair, we don't have either piece of these. So we're going to have to go in steps, aren't we? So what John chooses to do is he says, let's find angle B. He says, let's call this B. And let's find this angle. Then we can find all three by using the 180 trick, right? So he says, let's do 50 over the sine of 15 degrees equals 150 over the sine of b degrees. Does that make sense? Okay, we can't solve directly for L because we have neither the side nor the angle. And we would need one or the other of those in order to use the law of sines or the law of cosines. Okay, so we just have to go in steps. So we're going to solve for this, so then we can solve for that, so then we can solve for that. We use the law of sines because we do have a pair. We rearrange this and we get, this is just by cross multiplying and rearranging things, sine of b equals 150 times the sine of 15 over 50. Okay. And then we find that the sine of b, if we reduce all of that, we get the sine of b equals 0.7765. And then we use the inverse function because we have the decimal, but we want the degrees. And we get b equals 50.94. Okay, but again, we have to be aware of ambiguity because when we look at this, we can see, dude, that there's no way that's a 50-degree angle. That's definitely more than 90 degrees. So let's quickly consider a 50-degree angle would be like this, right? It looks sort of like that. But it could also be this angle. Sine is positive in both of these quadrants, right? So positive 50 could be either of these. This is the angle, right? This looks much more like this because it looks like it's more than 90 degrees. So then we do 180 minus 50.94 gives us 129.06. That looks like the right value for this one. Okay, now we found this angle. Now we can use our happy all angles add up to 180. We'll subtract the 15 and we'll subtract the 129.06. Those are our two angles that we do have, and that will give us a value of 35.94 for what we're calling angle L, right? So here was our first bit of work. Then I went up here to find angle L. Sorry. I'm just jumping all over this page. Now down here, we'll solve for L. So our first step was find angle B. Then solve for angle L. And now down here, we're going to solve for side L, which is what we wanted to do in the first place. Again, we could use the law of cosines, but we can also use the law of sines because we have the anchor. So we're going to use the law of sines, and we get, let's use our original anchor proportion, 50 over the sine of 15 degrees equals cute little side L over the sine of 1 Oh, I'm sorry, this. 35.94. I was thinking of this angle, but no, this is B. We don't want B, we want L, and there's L. It helps me to write my numbers on my picture so that the visual orientation of this really helps me, all right? So I can see 129. That's not the angle associated with this side. This one is. We had to find him. We've been running in circles. All right, so now I cross multiply and I say L equals 50 times the sine of 35.94 divided by the sine of 15 degrees. My calculator can make fast work of that, and I get L equals 113.39 feet. Hallelujah. That is the length of this cable. Isn't that cute? I was just reading a book where a man back in Texas frontier days was teaching a boy how to measure the distance across a river by using trig, and this reminds me of it. It's super fun and super practical. Trig is very, 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 very practical. It's used in navigating and measuring, surveying, things like that all the time. So triangles are our friends. Okay, that is the end of lesson 81. I hope that the law of cosines makes you smile, and I hope you feel very empowered by your ability to take triangles and crush them. Thank you, goodbye.